All right, number 1, it says a sample of 51 eggs yielded the mean of 1.58 ounces, assuming that, and you know that symbol stands for the population standard deviation, is 0.58 ounces. Find the margin of error. Okay, so this one is asking for error in estimating at a 95% confidence. Okay, so I'm not asking for the full interval. This is just the error. So you know to find error, we're going to take the z-score for 95%, which would be 1.960 times that standard deviation of 0.58 divided by the square root of 51. And that's just straight type in the calculator. If I can type times 0.58 divided by the square root of 51. And you should get 0.159, blah, blah, blah. But looking at the answer choices, you're going to round 2 decimals. And that would make that be 0.16 as the error. Did y'all get 0.16? Okay, good deal. Which is B's choice. All right, 2. It wants you to identify this study as observational or design experiment. And so it's lengthy, but it's got a weight loss program, 412 people considered to be at least 20 pounds overweight. They volunteered to participate in the study. The participants were randomly assigned to 1 or 2 groups over a 1 month period. The first group followed a particular diet, but were instructed to perform no exercise other than walking. The second group was given the same diet, but also performed aerobic exercise. So they had a different type of exercise. So this would be a design what? Experiment. That's a design experiment. Good. 3, a political pollster reports that his candidates has a 10% lead in the polls with 10% undecided. That's just straight observational. Yeah, straight observational. Okay, the next 3 was the ending of what we did out of Chapter 9. You being able to give the alternative and the null hypothesis. So it says, in the past, the mean running time for a certain type of flashlight battery has been 9 hours. The manufacturer has introduced a change in the production method, and they want to perform a hypothesis test to determine whether the mean running time has changed as a result. So the key word for your alternative is just it changed. You want to see if it changed. So the null would be that your U equals 9, but you're looking for the alternative to be what symbol? The not equal to sign, okay? And that's going to be what, A's choice? Mm-hmm. Very good. 5, all of that good stuff. I'm going to read the last sentence. A customer health group measured the level of the chemical in a random sample of tomatoes obtained from one producer to determine whether the mean level of the chemical in these tomatoes exceeds the recommended limit. So exceeds would be what? Greater than. And again, that would be A. Big deal. And then on 6, we're looking to determine whether the mean amount is actually less. So you're looking for what symbol? Less than, and that's going to be what, B? Yes. But making sure, now I didn't say this, you do know all you know is got to have the equal sign. Mm-hmm. So be careful, because D does have a less than on the alternative, but the null has a greater than sign. So make sure you know all your nulls got to have equals. So y'all good on 5, 6, 4, 5, and 6? Okay. 7, you're rolling on 2 die. And these are the possible outcomes. The question says, determine the probability that the sum of the dice is 7. So if you know about dice only have numbers through what, 6? So what's the possible way for you to get 7? Huh? Right. If I roll 2 dice, how do I make a sum of 7? I need a what now?
1, 6, 2, 5, 3, 4.
Very good. Okay. I need 1, 6, 2, 5, 3, 4. So that's how many out of that total? 6 out of his 36 listed, which will reduce to 1, 6. Very good. Very good. Because you do know you have these doubled. Okay? Very good. So that'll be 1 over 6. Does that make sense? No? Yes? All right. Number 8. Frequency distribution on employment at Alpha Corporation. Find the probability that an employee has been with the company 10 years or less. We've done these before. That's what, 35 out of 35 out of 78 gives you what decimal? 87, blah, blah, blah. But that's going to round to what?
449.
Good, 449. Okay? It's good when it's multiple choice. You can kind of know how you're supposed to round.
Or do you know whether or not your problem's right?
And you're right. If you don't see none of your answers close, well, we're all right.
Start over. I did. I had to pull out all my notes. I was like, oh, I remember this.
Number 9 and 10, these are confidence intervals. So on 9, this is the stuff that you just got your test back on. We got 30 randomly selected students, took a calculus final. The mean score was 80. And the sample, see that sample standard deviation is 12.2. Construct a 99% confidence interval for the mean score. So that lets you know you got to use the big table because it had the word sample in front of standard deviation. So if I got 30 students, I'm going to be on row what? 29. That's something you need to know to find it on the table, okay? So we're going to do 80 plus or minus. The last number on row 29 is what? 2.756, that's right, times 12.2 divided by the square root of 30. And you type all that in your calculator. I kind of already typed it in there. We got 6.138728,365, something like that. Keep it all in the calculator. Hit subtract and then go up there and hit add. And you see that they're doing 2 decimal places. So when you hit subtract, you should round it to 73.86. And when you hit add, you should get 86.14. Does that make sense? I didn't write the rounded numbers. I just wrote what it was when you rounded. 2 decimals. And that would be D's answer. Do y'all see that? Okay. Questions? Okay. 10. A laboratory tested 12 chickens, so N is 12 chicken eggs, and they found the mean cholesterol to be 226 milligrams. And do you see that's little s? So that means sample. Standard deviation is 17.9. Construct a 95% confidence interval for the mean cholesterol content of all eggs. So that means if you got 12 eggs, we on row what? 11? So we're going to do 226 plus or minus 2.201 is the z-score on row 11 at 95%. Times 17.6 divided by the square root of 12. My bad.
You said it right.
Oh, and I wrote it. I'm telling you, I'm off. 0.9 divided by the square root of 12. That should give you the error of 11.37319.409 that we're going to add and subtract from 226. So I'm going to go ahead and round one decimal place because that's what my answer choices are. 214.6 to 237.4. Very good. Y'all see that? I see. You ready to go.
I got it.
Number 11 is taking us all the way back to the beginning.
Yeah.
It says, identify the type of sampling in this example. You got a newly premiered play just ended that evening at a local theater. Theater management briefly interviews every 10th person leaving the theater. Systematic, very good. Because out of them, we only talked about the two S's, okay? We briefly went over cluster, I think, but we only really studied stratified and systematic. Stratified is where you take how many out of the freshman class, how many out of the sophomores. You take it a piece proportionally out of every group. But systematic is every nth person. Okay, very good. 12, determining between descriptive and inferential. This is the very first step. It says the table below shows the average income by age group of the residents in one town in the year of 1998. The average incomes for each age group are estimates based on a sample size of 100. Just putting that there makes it what? Inferential. Okay. Keep in mind, inferential has to be able to give you a clear population and sample. And when I stated, oh, the sample size is blah, blah, this, you go with inferential, okay? Now, if it's not clear, you got to go with descriptive, okay? Yeah. Like 13, it says a meteorologist constructs a graph showing the total precipitation in Phoenix, Arizona in each of the months in 1998. Does this involve descriptive or inferential statistics? That's descriptive. I can't give a true population and sample. Does that make sense? It says in Phoenix, but we don't know, it's not telling you enough information, okay? Does everybody understand the difference between the two? 14, it says find the mean. That's just simply add it up, divide by 10. That will give you B as in boy, $2,883.08. Did y'all get that? $15. Back to the confidence intervals. Laboratory tested 70 chicken eggs. We back on this cholesterol, and the mean was 190. Assume that, okay, now that little symbol means I'm using a little box. That's population. Standard deviation is 16.4. Construct a 95% confidence interval. So you're using the little bitty box because of that symbol. So we're going to say 190 plus or minus the z-score that matches is 1.960 times 16.4 divided by the square root of 70. That should give you an error of 3.8419428 that you're going to add and subtract from 190. So I'm going to go ahead and round one decimal. So that's going to give me 186.2 to 193.8. Which is A. Do y'all see that? 16, we got 30 students, so we know N is 30. We're randomly selected from a large group of students taking a certain calculus test. They like this calculus test. Mean score is 87. Assume that little symbol means population, right? I'm still using a little chart. It's 7.4. Construct a 99% confidence interval for the mean score of all students taking the test. So we're going to have 87 plus or minus 99% represents 2.576 times 7.4 divided by the square root of 30. That should give you an error of 3.48030216 that we're going to add and subtract from 87. And here they got 2 decimal places. You see that? So if you round it correctly, you should have 83.52 to 90.48. Y'all see that? Still okay? 17. Still a confidence interval. We got a sample of 32. And it says the sample mean is 3.1 minutes. And assume the population standard deviation is 0.94. Construct a 90% confidence interval. So we're going to say 3.1 plus or minus, the z-score is 1.645 times 0.94 divided by the square root of 32. Have this one on the paper. 0.273349804. And I'm going to keep in that calculator that I'm going to subtract from 3.1. And this is rounded, what, 2 decimals? So this is 2.83 to 3.37. Which is what, D? Questions? Now 18 is wanting you to find the value that's missing. So that's the row for 45 to 59. So they're giving you the relative frequencies. So we know all relative frequencies equal what? Right. So what number? If you want to do it on percent, all of your relative frequency column has to equal who? 100, but in decimal form it equals 1. Okay? So you can add these up, and when you do, you get 0.60, which is 60%, if you want to look at it that way. If you subtract 60 from 100, that gives you 40%, which would be 0.4. Or you can say 1 minus 0.6, and it gives you 0.4, okay? But you do need to know relative frequency is based on 1, or if you want to do it in percent, it's 100. So y'all do know it's 40, 140. And you do know you got to give me C answer, not A. Do you see they gave 40%? The answer is asking for relative frequency. Relative frequency is a decimal. So it has to be 0.4. Y'all make sure y'all know that. Okay? All right. 19 and 20 are hypothesis tests. So that's the last thing we did, and that's using the last little bail, which are critical values. Now, it might be hard to read, but they've given you a null and an alternative hypothesis. That's where you're going to get your mean from, okay? So you need to find the actual z-score. So to find that z-score, you know you're going to take the sample mean minus the population mean divided by standard deviation divided by the square root of n, okay? So on 19, we're going to take 21.3 minus, if you look over there where it's got those null and alternative hypotheses, the mean is 18.7. Does everyone see where you see that? Divided by the population standard deviation is 7.6, divided by the square root of 11. So when you type that in, you're going to get 1.13. Okay, it's a rounded number, but 1.13. And do you see in your multiple choice, they kind of have that z-score listed. Now, you're going to look at your Bayes, and if your alpha is at 0.01, that critical value, now keep in mind, my table, my Bayes is rounded to decimal places. So it says 2.58, but if you look at the multiple choice, you do know that's the same as 575. Okay, that's the same. So we're looking at, if this is the Z, we know 1.13 falls inside of 2.575, okay? So we're going to keep, and you do know keep means the same thing as do not reject, okay? So that's going to what? B answer? Make sure everything matches. Your z-score is 1.13. Your critical value is positive negative 2.58 rounded. And you do not reject the null. Do y'all see that? Okay. 20. We have the same setup. We're going to get the z-score. And that's going to be 20 minus 22. Y'all see where 22 is? And then that's going to be divided by 1.5 divided by the square root of 60. And when you type that in your calculator, you get a whopping negative 10.33. Now, honestly, I wouldn't have to look at that on the table at all, because that's way over my numbers. Okay. Does that make sense? Your table don't go but past negative 3.3 and positive 3.3. So we know definitely this is a what? Reject. Okay. And that's going to match which one? C? Make sure you got the right critical values.
I thought I was so wrong on that. I seen the number, I was like...
Yeah, but you got to make sure you match the critical value right. Mm-hmm. Which at that alpha level, 0.05 is 1.96. Mm-hmm. Yeah. Does everyone see how you do 19 and 20? Okay.
As long as you got them grads on there.
Now, 21 wants you to find the standard deviation. And this is how we was taught from the beginning. This is sample, okay? This is the table, chart method, all right? So, I'm going to put it up here like the table. So, we're going to do all of these X's, which is 7 of them, 42, 11, 36, 29, 14, 50, and 64. And the very first thing you need to do is find the mean. When you add all of them up, you get 246. And when you divide by 7, you're going to get a decimal. Now, I would do 1 decimal. You probably did 2. That's fine. I just don't want your table to get so big, okay? But your mean... I got 35.1. Those, did anybody work this one?
No, I didn't.
Already?
I worked it already, but I have the number paper at home.
Okay.
Yeah,
I was wondering, did anybody do 2 decimals or 1 decimal? That's what I was asking. 2. That's fine. It'll be 0.14, and that's fine. If you go back, it says round your final answer, 1 more decimal. It's really not, the answer choice is not really following that rounding rule, but oh well. So if you use 1 decimal, you're going to get 6.9, negative 24.1, 0.9, negative 6.1, negative 21.1, 14.9, and 28.9 when you subtract, and then you double, you're going to square it. And everything in this column is going to be positive, right? And I would just make sure I add it twice. Just check yourself. Just add this stuff twice. But, and then 8, 35, 21. And so when I worked it, I got a total of that last column and ended up being 21, 68, 87. And so our formula says that we're going to take that sum and divide it by one number less than x, okay? So there's total number of 7 different numbers. So we're going to take that 21, 68, 87 and divide it by 6 and then take the square root or do it all together, however you want to type it in your calculator. But when you divide by 6, you're going to get 361 point something. Take the square root of that number, and you get 19.01 and some other stuff. So it looks closest to A. Okay.
Let me get on this there real quick.
But I want to make sure y'all do brush up on this chart method because you got one sample standard deviation problem, and it's going to be the chart method. Yes. They typed up, so I ain't got to remember to put them on the board. They typed up on the actual sheet. You're going to actually get a packet. Like, it's going to be the formula on top, and then it's all these graphs, all these tables. Okay? So you don't bring anything with you but your calculator and pencil. I'll provide all this all over again. Okay? And the formula sheet's on top. All right, 22. 22 wants you to find the sample size, okay? So we have standard deviation of $532 and the error is 130. And we're using a 95% confidence interval. So to find the sample size, you know you're going to take the z-score times the standard deviation divided by the error, and don't forget to do what with it? Square it. Please don't forget to square it. So at 95%, that represents 1.960 times 532 divided by 130. Yeah, you get this number, 8.020923077. Keep that in the calculator. And when you square it, you get 64, blah, 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 blah. But you always do what? You always round up. So your answer would be 65. Very good, 65. Got that? 23. It says five number summary. This comes from box plots. Okay? Now, I said the 5 number summary, but on my test, I was just you had to do everything, okay? But what's consisted of the 5 number summary is the minimum, Q1, Q2, Q3, and the max. That's what's in the 5 number summary, okay? Your minimum and your max, and then your box itself, Q1, Q2, and Q3. So your numbers are in order, but that's the first thing you got to make sure is these numbers are listed in order from least to greatest. And we got 7 numbers, so we got an odd set. And you know what an odd set, you got to take that middle number and share it to both ends, okay? So if I find my Q2, which is dead in the middle, that's going to be 8. Y'all agree? Now, when you do Q1 and Q3, that's where you're going to use 8 with the 1, 4, 5, and then you're going to also use 8 with 10, 11, and 13. Does that make sense? So when you look at the lower end, you're going to have 4 and 5 in the middle, and that's going to, you're going to add it up and divide by 2, right? And that's going to give me 4.5, which is your Q1. Does it make sense? You find the average. Then on Q3 side, you're going to have 10 and 11 in the middle. Does that make sense? You add them up and divide by 2, and you're going to get 10.5, and that's going to be Q what? 3. Do y'all see that? And so automatically your minimum is 1, and your max is what? 13. So you're looking for the choice that has 1, 4.5, 8, 10.5, and 13.
I did that right, didn't think about it. I was like, just me. Hold on, wait a minute.
Okay. Is
I'm
it?
gonna be honest, I had nothing before I came to this class. I didn't remember how to do this.
I didn't even think about doing
I
that.
didn't remember how to do.
Find the, what am I finding? Oh, point estimate. I was like, what's the question? 24 says find the point estimate. All that stands for is the mean. Okay? You're finding the mean. So you're going to simply add it up and divide by 16 because it's 16 numbers listed. So I got 12, 195. And when you divide it by 16, you get 762 point blah, 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 blah. That's going to round to 762. Do y'all see that? 25. Ask you to find the area that lies between 0 and 3.01. So if you're going from the middle directly to that z-score, what picture is that? Mean and z.
Oh, really?
Remember, body got to go over the middle. I'm asking you to start at the middle. Does that make sense? I'm saying start at 0 and go to 3.01. That's going to be straight mean and z. Okay? So if you go look at 3.01's mean and z-score, you just get 0.4987. That's that measurement. Y'all see that? (26), you are to find what measurement? That's tail for 209. And that's going to be .0183, and you got to multiply it by 2, right? And that should give you .0366. 27, that's what picture? Mean and z. So for what, 92? 92's mean and z is .3212, but you also got to multiply that by what? 2. By 2. And that gives you .6424. Okay. 28. I love these charts. much monitor. All right, on 28, it's asking A and B. So these have to overlap, right? That's what and means. So A says the student is between 21 and 35. So this group, right? B says that the student is 26 or over. 26 or over would be what? Right. So the two that's in both boxes is who? The 1142 and the 878. So if you add those two up, you get 2020. And has to overlap. They got to be in both spots at the same time. Does that make sense? I remember saying my grace. $29. Come on, Florida. All right, and this one says or. So A says that the student took at most 8 hours. So that would be 8 and below, right? The most you can have is 8 hours. And then B says that the student took at least 8 hours. So that would be what? 8 hours and up. I was having a moment. Now, or means I need to know the total. But in this case, everybody is in a box, right? So all you need to do is add up all of that together. Okay? That's what or means. Or means I want to know how many is in both groups, which that's going to be everybody. And that gives you a total of what?
113.
Good, 113. Okay. 30. Find the z-score for which the area under the standard curve to its left is 0.96. So y'all do know that's a what measurement? It's a body, right? It's a body. And so you're going to look under the body column for 0.96. And when you look at your choices that's given, the others, the 175 is going to be your closest because you do have multiple choice, okay? When you look at 175, it's going to say 0.9599, and that's not but what? One number, okay? So that's going to be the z-score we're going with. But here, you can, if you just wanted to, you can go check them out, look at them and see what they say, but that's going to be the closest. 1.82 going to be 56 over. That's a point at 96.56. So that's a little far. Well, by instructions, go with the next page. It just got chopped. 31 says construct a bar graph for the relative frequencies. So really you're checking to see between A, B, and C which one of them are going to match that exactly. You follow me? You're not drawing it yourself. But if you look for 44, the first one, definitely A can't be it because the bar is under 40. You see how I just eliminated that one? O has to be at least 44%. It ain't going to be on A. Now, B and C are above 0.40 for O. Then I check my A spot. We got to be at 38. Okay, they both at about 38. That's below 0.4. Then B got to be at 12. That's going to be the problem. Your B is going to be more C. Because over here on the B choice, the B blood type is almost at .20. So it's got to go with C. Does that make sense? And then 32, you constructing a stem and leaf. So really, basically, you're looking to see which one
Has all the numbers.
has all the numbers. Now, I will say this. This is not, either one of them are really correct. Because a true stem and leaf, your leaves are in order from 0 to 9, okay? But because you only have two choices, you got to go with, you got to at least cover all the numbers. You follow me? So when I look at it, I was starting off looking at the first one because 3, 5, and 8 was in order for the row 6. But when I look at row 7, it don't have a 73. It don't even have a 55 up there, nor a 78. You follow me? The row 7 is all the way off. It's got numbers that ain't even listed. Does it make sense? So B got to be the answer because it has the numbers that are listed. Huh? You made your own, and that might be smart. Make your own and then match it. See which one it matches.
Then I went back and cross-referenced.
Right, that was good. All right, here we go. 33. I need to know what type of hypothesis test. So I'm looking for the last sentence. To perform a hypothesis test to determine whether the average amount of time spent watching TV has decreased. Left tail, good. 34. Determine whether the mean score for trial lawyers exceeds right tail. And then hypothesis determine whether the mean running time has changed. Two tail, very good. 36 wants to know what kind of data is provided by the information in the first column. The first column ain't nothing but names, type of media. That's qualitative. Quantitative would be the sales. Does that make sense? It's money. Quantity means number. Does that make sense what I'm saying? The one with quality, that's going to be non-numerical. So that would be the answer, A. $37. Find the mode or modes for the data. What number or numbers appear the most? 4.7 is up there 4 times. 5.9 is on up there 3 times. So a true mode is when you occur the most. So that's 4.7. Does it make sense? Now, if 5.9 would have been up there 4 times, they both would be it, okay? Now, this is strictly using this table, the T-curve. So if I'm asking you for a T-curve value on DF24, where your sub number is 0.005, you do know that means 99%. Last number on row 24 would be who? 2.797. Very good. Do y'all see that? Then I gave you 2 of them. 39 asks you to go to row 11 and you find in point 10, which would be the very first number, the 80%. On row 11, what number would that be?
1.363.
Very good, 1.363. Y'all see that? That's just looking off the table. Okay, on 40, find the median, which would be the number in the middle. So you would have to put them in order now from least to greatest. And this one's going to have 2 numbers in the middle. So you're going to add them up and divide by 2, and you should get C, $4,884.50. Right? Okay, 41 wants to know the type of data. Is this discrete or continuous? The total number of phone calls a sales representative makes in a month is $425. Now, what have we talked about? This has been a while, though. A discrete number is a whole number. Okay? That's a bad way to call it. But it can change, but it's not in pieces. I can only make 425 calls or more or less. I can't make 425 calls in a half. Does that make sense? That's continuous. Continuous is when you got two pieces. Okay? Does everybody understand the difference? So that should be discrete. That's a discrete number. Okay? 42, be able to tell me the sample in the population, 100,000 randomly selected adults were asked whether they drink at least 48 ounces of water each day. Only 45% says yes. Now, obviously, there's more than that many adults. Okay? 100,000, that's not enough adults, if you think about it. So that's strictly your sample. Your population would be what? All adults. So that would be what? D? Okay. 43. It says list the outcomes that comprise the event, not A. Well, what does A say? Helen gets the first prize. Okay? That means H has to come first. Don't count the ones where H comes first. So that's going to be everybody but HJ, HG, and HM, right? So you need to make sure everybody else is listed. But them three. So that's going to be which one? D as in dog. Good. And the last one, 44, it says, in a clinical trial, 780 participants suffering from high blood pressure were randomly assigned to one of three groups. Over a 1-month period, the first group received a low dosage of an experimental drug, the second group received a high dosage of the drug, and the third group received a placebo. The diagnostic blood pressure of each participant was measured at the beginning and the end of the period, and the change in blood pressure was recorded. Identify the response. What are you looking to happen in all three groups? Change in the blood pressure. Good. You're looking for the change in the diagnostic blood pressure. That's it.